Welcome to Bedtime Astronomy. Explore the wonders of the cosmos with our soothing Bedtime Astronomy podcast. Each episode offers a gentle journey through the stars, planets, and beyond, perfect for unwinding after a long day. Let's travel through the mysteries of the universe as you drift off into a peaceful slumber under the night sky. Pathfinders to the stars. The epic journeys of Pioneer 10 and 11. Pioneer 10 and 11 represent milestones in human exploration of the outer solar system, embodying the first missions to traverse the asteroid belt and provide humanity with direct observations of Jupiter and Saturn. Launched during the early 1970s, these twin spacecraft were products of NASA's vision to push the boundaries of space exploration, heralding a new era of interplanetary discovery. Each probe was designed to withstand the harsh environments of deep space and was equipped with advanced scientific instruments capable of capturing data on planetary atmospheres, magnetic fields, and radiation belts. Pioneer 10 was launched on March 2, 1972, atop an Atlas Centaur rocket from Cape Canaveral, Florida. It became the first spacecraft to journey through the asteroid belt, a region previously deemed perilous due to potential collisions with debris. The mission's success in navigating this region demonstrated the feasibility of safe passage, paving the way for future interplanetary missions. By December 1973, Pioneer 10 achieved a historic milestone by becoming the first spacecraft to encounter Jupiter. It sent back stunning images of the gas giant, revealing intricate details of its swirling atmosphere and massive storm systems, including the Great Red Spot. The spacecraft also measured the planet's intense radiation belts, providing critical data for subsequent missions to the Jovian system. Pioneer 11, launched on April 6, 1973, followed a similar trajectory but was programmed for an even more ambitious mission. After successfully passing through the asteroid belt and conducting its own observations of Jupiter in December 1974, it used the planet's gravity to slingshot toward Saturn. This pioneering use of gravitational assists enabled the spacecraft to reach a planet that had never been visited before. In September 1979, Pioneer 11 flew within 21,000 kilometers of Saturn, capturing unprecedented images of its rings and revealing the existence of new moons. The data collected by the spacecraft also shed light on the composition and structure of Saturn's magnetic field, providing insights into its internal processes. Both spacecraft were equipped with a suite of scientific instruments, including imaging photopolarimeters, magnetometers, and plasma analyzers. These tools allowed the missions to measure particle densities, cosmic rays, and solar wind properties across vast distances. Additionally, each Pioneer probe carried a gold anodized aluminum plaque, engraved with a message intended for any extraterrestrial intelligence that might encounter the spacecraft. Designed by Carl Sagan and Frank Drake, these plaques depicted human figures and a schematic representation of the spacecraft's origin in the solar system, symbolizing humanity's attempt to communicate across the cosmos. The engineering behind Pioneer 10 and 11 was as innovative as their scientific objectives. Both spacecraft were powered by radioisotope thermoelectric generators, RTGs, enabling them to operate far from the sun where solar energy was insufficient. Their robust design allowed them to endure extreme temperatures, radiation, and the vast distances of deep space. Despite these challenges, they continued transmitting data long after their primary missions were completed, with Pioneer 10's final signal received in 2003, at a distance of over 12 billion kilometers from Earth. The success of Pioneer 10 and 11 was not merely a triumph of engineering. It was also a profound leap in our understanding of the outer solar system. Pioneer 10's encounter with Jupiter provided humanity with its first close-up observations of the largest planet in our solar system. The spacecraft's imaging system transmitted vivid black and white photographs of Jupiter's swirling cloud tops, offering unprecedented insights into the planet's dynamic weather systems. These images showcased Jupiter's turbulent atmosphere, characterized by bands of alternating colors and complex storm patterns, including the iconic Great Red Spot. The data also confirmed the immense strength of Jupiter's magnetic field and the scale of its radiation belts, which were far more intense than anticipated. These findings would later inform the designs of subsequent spacecraft, such as Voyager and Galileo, ensuring their instruments could withstand such harsh conditions. The scientific yield from Pioneer 11 was equally transformative. Its daring flyby of Jupiter allowed scientists to refine their understanding of the planet's gravitational field, providing critical data that guided its trajectory toward Saturn. Pioneer 11's passage through the Jovian system also offered a closer examination of the planet's moons, including insights into their orbits and interactions with Jupiter's magnetosphere. This journey laid the groundwork for more detailed studies by later missions. When Pioneer 11 reached Saturn in 1979, it marked a turning point in planetary science. The spacecraft's flyby provided the first detailed observations of Saturn's rings, revealing their intricate structure and dynamics. Pioneer 11 discovered the thin F ring and confirmed that the rings were composed of countless icy particles, ranging in size from micrometers to meters. These observations raised new questions about the origins and evolution of the ring system, inspiring decades of subsequent research. The spacecraft also identified several new moons orbiting Saturn, contributing to the growing catalog of the planet's diverse satellite system. Among these discoveries was evidence of irregularities in Saturn's outer rings, hinting at complex gravitational interactions with its moons. Beyond its contributions to planetary science, Pioneer 11 delivered valuable data about the interplanetary environment. Its instruments recorded detailed measurements of solar wind properties and cosmic ray intensities, deepening our understanding of the space between planets. As the spacecraft moved farther from the Sun, it provided early clues about the boundary regions of the heliosphere, the vast bubble of charged particles emanating from our star. This information was crucial for shaping the objectives of later missions like Voyager and, more recently, the Interstellar Boundary Explorer, IBEX. The engineering challenges faced by Pioneer 10 and 11 were immense, yet their designs proved remarkably resilient. Both spacecraft relied on spin stabilization, a technique that maintained their orientation in space without complex gyroscopic systems. This simplicity was key to their longevity, as fewer moving parts reduced the likelihood of mechanical failure. Additionally, their onboard computers were primitive by today's standards, with memory capacities measured in kilobytes, yet they were sufficient to execute their ambitious missions. The spacecraft's RTGs not only provided consistent power but also enabled their instruments to operate in the frigid depths of space, where solar energy was unavailable. As the Pioneers ventured farther from the Sun, their signals grew weaker, yet they continued to send back data well beyond their expected lifespans. By the late 1980s, both spacecraft were providing unique insights into the outermost regions of the solar system, including the distribution of interstellar dust and the gradual decline in solar wind intensity. These observations extended humanity's reach into interstellar space, hinting at the vast, unexplored frontier that lay ahead. The legacy of Pioneer 10 and 11 is deeply embedded in the history of space exploration, serving as harbingers of humanity's reach into interstellar space. As the first man-made objects to venture beyond the known solar system, they symbolize a bold step into the vast unknown. Pioneer 10, after completing its historic flyby of Jupiter, continued to journey outward, crossing the orbit of Pluto in 1983 and entering regions where the Sun's influence wanes. Its signal, last received in 2003, marked the end of a remarkable mission that had spanned over 3 decades and redefined the limits of human ingenuity. By the time communication was lost, Pioneer 10 was over 12 billion kilometers from Earth, heading in the direction of the constellation Taurus. Pioneer 11's path similarly charted a course into the cosmos. After its encounters with Jupiter and Saturn, it became the first spacecraft to explore the distant regions near the heliopause, the boundary where the Sun's solar wind gives way to the interstellar medium. Though its mission officially ended in 1995 when NASA ceased regular tracking, Pioneer 11 continued to drift silently through the void, carrying its golden message to the stars. The spacecraft's trajectory is aimed toward the constellation Aquila, and though it will take millennia to reach another star system, it stands as a testament to humanity's enduring curiosity and desire to communicate across the cosmos. The golden plaques aboard Pioneer 10 and 11 are among their most enduring contributions to the human story. These artifacts, designed by Carl Sagan and Frank Drake, were etched with a wealth of symbolic information: diagrams of hydrogen's atomic structure, a map showing the Sun's location relative to pulsars, and depictions of a man and woman standing in front of the spacecraft. The plaques were crafted as a message to any extraterrestrial intelligence that might one day encounter these emissaries from Earth. They also served as a reminder of humanity's shared place in the cosmos, transcending national borders and eras of history. Though the likelihood of the plaques being found is infinitesimally small, their inclusion reflected a profound optimism about humanity's role in the universe. The scientific impact of the Pioneer missions extended far beyond their original goals. Their findings about Jupiter and Saturn set the stage for the ambitious missions that followed, such as Voyager, Galileo, and Cassini. These spacecraft expanded on Pioneer's discoveries, delving deeper into the complex dynamics of planetary systems and their moons. Moreover, the Pioneer's exploration of the heliosphere provided critical groundwork for understanding the Sun's influence on the solar system, insights that continue to inform missions like Parker's Solar Probe and the upcoming Interstellar Mapping and Acceleration Probe, IMAP. Today, the Pioneers continue their silent journeys through interstellar space, no longer sending signals but still carrying the story of Earth. Their paths are trajectories of hope, curiosity, and the indomitable human spirit. As they drift endlessly among the stars, they remind us of our smallness in the cosmos and our capacity for greatness. The missions of Pioneer 10 and 11 are not merely about exploring the solar system. They are about expanding the horizons of what it means to be human, venturing into the infinite with courage, creativity, and a boundless sense of wonder.